All right, so we're on 6-1, functions, systems of equations, and two variables, okay? Basically what it means is that you have x and y at the same time, and they're both unknowns to some degree. Please don't do it. Okay. Block me out. You're right. X and y and two variables. So we're going to go through using all the different methods. So reading a graph, reading a table, solving by substitution, and elimination. So the first thing that we're going to talk about is being able to evaluate using two variables at a time. Okay, so first here, notice that it's saying that you have the f of 2, 3. What this is telling you is that you have an x and a y. So can you evaluate the expression using x and y? Yes. So I'm literally just double substituting. So I have 2 times 2 minus 3 times 3, which is going to give me 4 minus 9, which equals -5, right? Okay. This is also used when it's not x and y, when you're describing certain parameters of things. So for example, with volume, if I'm looking for the volume of a cylinder and I know the radius and the height, can I find the volume of the cylinder? Yes, because I have the two variables that are needed. So it tells me that my radius is 3 and my height is 2. So the volume of the cylinder is going to be 1/3 pi times 3 squared times, that's a 2. So that gives me 1/3 pi times 9 times 2, which equals 6 pi. Why is it 6 pi? Because 9 times 2 is, and 18 divided by 3 is 6. So it becomes 6 pi would be what that simplifies down to. Bless you. Okay. All right. So types of systems. We have 3 types of system. We have the option where there's one solution, and we call that consistent and independent. That means that the two lines are going to intersect. We have another possibility of infinitely many solutions, okay? So if you have infinitely many solutions, what that means is that when you simplify those two equations, they created the same thing, okay? So when they were simplified, they came down to being the same equation. So they have the same slope, same y-intercept, which we call consistent and dependent system. Lastly, we have 0 solutions. So if I have 0 solutions, that means that these two will never ever touch, and we call that an inconsistent system. So with one solution, that means that they have different slopes. With infinitely many, that means they have the same slope and y-intercept. With 0, that means they have the same slope, but different y-intercepts. So if I'm looking at two equations and I'm trying to decide whether it's going to be consistent and independent, I'm paying attention to its slope and its y-intercept. Okay. Questions about identifying? Cool, go for it. All right. So how do you solve a system of equations? By graphing. Step number 1 is you want to write it in each equation in slope y-intercept form. So y equals mx plus b is where you're going to start off with, right? Step 2 is you're going to graph each equation using the slope and the y-intercept as your graphing tools. And then step 3 is to figure out where did they intersect at and test that value into the equation. Easy enough. So get y by itself, graph, find an intersection. So we're going to do it here. So for example, I have easy, short, small numbers. So we have x minus y equals 1, and we have negative x plus 1 equals -1. So first, to get this, where y is by itself, in order to get y by itself, I'm going to end up with x minus 1 equals y, correct? All I did was add the 1, and subtract the 1, add the y. Doesn't matter which way I went. Nope. To get y by itself here, I'm going to end up with y equals x minus 1. Okay, right off the bat, what do I notice is happening here? I did something wrong? They have the same slope, same y-intercept. So what does it tell me my solution is going to be? Infinitely many, okay? Because their slope and their y-intercept are the Same. So what this means is that when I graph, no matter which one I graph first, it's still just going to be one line on my graph paper. Does that make sense? So if I go to -1 and sketch this out, I have to draw the dots to try to draw a straight line. Don't judge. Is it still going to be straight? Probably not, but it's my attempt.
It's not bad. Compared to some of the other.
Exactly. That's why I have to put the dots. The dots, it helps me do a little bit better. So no matter how many times I graph this, it's still just going to be one line. So the solution here is, this is what we call a, let me go back, a consistent and dependent, and our answer is infinitely many. Does that make sense?
Question.
Yes.
Will you have us answer as consistent and dependent, or can we just put 0 infinitely many? Or...
It depends on what it's asking. So it asked me here, it says, is the system consistent?
Okay.
And if it is, state. So based on what it's asking us, I'm answering it. Consistent. And it is dependent.
So is 6.2 going to be with 3 solutions?
6.2 is just inequalities, is what's shading.
Okay, so we're just done with 2 solutions.
Consistent, dependent, and that means that we have infinitely many solutions. Okay. All right. So next, here, this one may not be as direct. So we're going to, again, get y by itself. So when I get y by itself here, I'm going to end up with y equals, and I have 2/3 x minus 1/3. Are we comfortable with that? Yeah. So I subtracted the 2x, and then I divided by -3. Okay, now we get y by itself here. So getting y by itself here, that equals -1/2 x plus 2. Okay, so looking at the slope here, I know that I have different slopes, correct? So because I have different slopes, I know that I'm going to have consistent but independent system. Does that make sense? So my slopes are different. So I know it's a consistent and independent system, which means that I have one solution, one point of intersection. Let's go. All right, so I'm going to do my best to graph this. Let's see. If I let x be, because this one's not easy, 1/3 is not easy to start with. I can do y equals 2. So let's do the bottom one first, graphing. I'm gonna go to 2, 1, 2. And I know that my slope is down 1, right 2, down 1. I'm gonna go up 1, left 2, up 1, left 2. That's because I have to create a decreasing line, correct? Okay, so that works great when your y-intercept is a whole number. You can use that strategy to graph. But when your y-intercept is not a whole number, such as -1/3, you have to choose another value to start finding your slope from. Okay, so let's say I chose, what would be a good number? 2 times, I use 3. 2 times 3 is 6. No, that's not gonna be easy either. 6 minus 1/3 is not pretty. So if I did 3, no, it's not pretty. 2. 2 is 4. Yeah. So if I plug in 2, if I go to x equals 2, what's 2 times 2? What's 4/3 minus 1/3? And that equals 1. So I know that at 2, it starts at 1. Oh my gosh, it starts right on where they intersect. So I know I'm here, and from there, I can follow my slope, which is I rise 2, and I run 3. 1, 2, 3. Rise 2, 1, 2, run 3. And reverse, fall 2, crawl 3. Fall 2, and 1, 2, 3. Fall 2, and 1, 2, 3. Okay. So now, like I said, this is a consistent independent, and there's one point of intersection, and that one point of intersection is at my solution, which is 2, 1. Okay, so again, do we see the difference in how to graph when it's a and an integer? So if I'm given an integer as my y-intercept, I can start at my y-intercept and rise over run. If I'm not given my integer as my y-intercept, I have to find a value that I can substitute in to create a starting point. Okay, that's when you have to do it manually by hand. Okay, do we need to do another example, or are we okay? The next one is a parallel, if y'all need to see parallel. We're good? All right, parallel just means the slopes are and so is no, it's not.
I was like, where are you going?
Just slopes are the same. That's because they'll never, ever, ever touch each other. We're on the same path. We just started at a different location. All right. Why are systems useful? Here's a real world example of a use of a system. If someone is in marketing and they're trying to compare revenues and sales and figure out what's the best. It says in 2010, the revenues at McDonald's and Burger King's were 26.4 billion, and Burger King's revenue was 21.8 billion. Okay. Write a system of equations whose solution gives their individual revenue of each company in billions of dollars. So if I was to write a system here, remember your revenues are your profits minus your expenses, right? So your cost minus your profit is your profit minus your cost is your revenue. So for McDonald's, they have their own. So we would know that McDonald's equals their own P minus C, and their P minus C equal 26.4, right? Burger King has their own P minus C, and their P minus C has to equal 21.8 billion. Oh, I read that totally wrong. Scratch what I just said. You heard nothing. Thank you for saying because I don't know what I wrote. I was just confused as me too. McDonald's plus Burger King. Keyword is and. M plus B equals 26.4. There we go. Does that make it better?
No.
Sure. I really wish I could just turn my pen upside down and it becomes an eraser.
That would be nice.
It would. Is that better? Okay. It says McDonald's revenue exceeds Burger King. So McDonald's exceeds Burger King by 21.8. It's not like I haven't written this 3 times before in my life. There we go. So now, could I find the solution to the system? Yes. So in this example is an example of us leading into our substitution method. Okay. When substitution, why substitution method is useful is that I already have the one of the variables isolated. Does that make sense? And so if I already have one of the variables isolated, I can substitute that in and solve for what a piece of the information. Since I already know what M equals, I can substitute that in. And I get B plus 21.8 plus B equals 26.4. And then now this just becomes an algebra 1 problem. I have to simplify and isolate, right? So what would I need to do to get? So we combine, isolate. So I'm going to combine. I have B and B makes plus 21.8 equals 26.4. And then I need to subtract the 21 and 8/10. Well, 8 millions. And that gives us 4.6. 14 minus 86, right? So we're left with 2B equals 4.6. So Burger King's revenue was 2.3 million. So Burger King's revenue out of that is only $2.3 billion. Right? That's like, oh dang, Burger King, why are you still in business? I mean, it's billions, so that's probably why they're still in business. I personally keep Burger King in business, so I do. I like Burger King. McDonald's therefore had the other part, and how much did McDonald's have then? Well, that 21.8 plus 2.3, which puts them at
24.1. Right?
I think so. Sounds right. Sounds good. Yes, because you got to carry. So 24.1 billion. Why? Why do y'all think that is? Anyone? I think it's locations. McDonald's are everywhere. Really? See, me and my son like Burger King better. Their chicken is actually good too. Yeah. So you won't even try it. Well, it's better. And their line for breakfast is never long.
Not because it's not good.
Huh? Because people are haters and underestimate it. And Wendy's also has a good breakfast and their line's not long either. So I'm just saying.
Better than I was.
Yeah, it's actually pretty good.
I like their chicken.
So I'm just saying, y'all can keep going to that. The McDonald's with the possible crack in it. But
You know what? It has red eggs.
ignore it. I don't know. I don't eat McDonald's that often. My little one, he's obsessed with McDonald's.
I feel like all little kids are though.
Yeah.
I did well with this.
All right, here we go. So remember I said that was leading us into our what method? Substitution. Okay, that was an easy substitution one. But when you're substituting, basically all you're doing is you're solving for one variable in at least one of the equations, and then you're going to substitute that in to the other equation, and then you are going to solve, get that value, and then substitute back in to the original. And then when it's all said and done, and you want to check yourself, you're going to take those two values and plug them in and make sure it works. Okay, it's just substitution, substitution, substitution. You learn it in algebra too. No. All right. Here we go. So for example, here we have 3x minus 2y equals 5 and x plus 5y equals 13. This is a good example of substitution because I have a variable with a coefficient of 1. I have x, right? It has a coefficient of cast for the friendly 1. So I can isolate x and then substitute that in. So that's what we're going to do. So I'm going to first get x by itself. In order to get x by itself, I'm going to have to do what? So now we know that x equals 13 minus 5y. Because I don't like leading with the negative. It's the same thing.
Well, -5.
If you want to switch it, switch it. It's the same thing. All right. So now step 2 is I'm going to take what I got and I'm going to substitute this into the other equation. So 3 times 13 minus 5y minus 2y equals 5. Yes. Still. All right. Now you're at step 3. Step 3, you're going to solve for that variable. So we distribute, combine, isolate. Distribute, combine, isolate. Got it? So we're going to go ahead and distribute. And that gives me 39 minus 15y minus 2y equals 5. Now I'm going to combine like terms. So combining like terms, I get 39 minus 17y equals 5. And now we're down to the isolate. So I need to isolate the variable. I need to get y by itself. What are the 2 steps I have to take to get y by itself? Subtract 39 Done. And
Divide by -7.
and then divide by -17. So I'm subtracting 39 and dividing by -17. That gives me -34 divided by -17. And it is 2. So y equals 2. So we, huh?
I thought it was two. Oh, yeah, it's two. I'm like at the very end.
Oh, you're on step 4 where you plugged it back in for x? Okay. I was like, I'm pretty sure 34 divided by 17 is 2. I'm wrong on a lot of things, but all right. So now step 4 is you take what you have and you plug it back into your step 1. So in step 1, we were looking for x. So now we know x equals 13 minus 5 times 2. What is 13 minus 5 times 2? 3. So we know x equals 3. So our system solution is 3, 2. Yeah. Is this ringing some bells? Seems a little familiar to somebody. Hopefully everybody. Yeah. We're cool with substitution. Do we need more examples of substitution? Are you being funny? We have time. All right. So the difference here between algebra 2 and pre-cal, not algebra 2 and algebra 1, is that now you also have it with quadratics, which we kind of touched on a little bit in algebra 2 at one point, but we didn't emphasize. You also now work with a quadratic. So if you have a quadratic intersecting a line, which means that instead of having only one solution, you may have 2 solutions because that line may cross it twice. Does that make sense? So if I have a parabola and a line goes through it, I now have a chance of hitting it twice. So this is going to be an example of a possible 2 solution situation. And it's 2 solutions because I have a linear and a quadratic. Yes? All right. So again, you're going to choose a variable that's easy to isolate. The variable that's easy to isolate is y, because it has Casper the friendly ghost of 1. So when I isolate y, I get y equals, and you can write it however you want, 5 minus 3x squared. Okay. Step 2 is now to take that and substitute it into the other equation. So we have 5x plus 3 times 5 minus 3x squared equals 1. Okay, so we're going to simplify. The difference here is because we're dealing with a quadratic, we're no longer distribute, combine, isolate. Okay, we have to distribute, combine, set equal to 0. That's where we're at now. So the new rule here is distribute, combine, and set equal to 0. And why is that? How do you solve quadratics?
I see.
You by setting equal to 0 and either factoring, quadratic formula, or yeah, that's good. Okay, so we're gonna go ahead and distribute. So now we're at step 3. We have 5x plus 15 minus 9x squared equals 1. And again, our goal here is to distribute, combine, but set equal to 0. So in order to set equal to 0, what am I going to have to do to this 1? Subtract it. And what I do to one side, I have to do to the other. So I'm now working with negative 9x squared plus 5x plus 14 equals 0. If you have strong factoring skills, you can factor at this point. If you don't have strong factoring skills, sing it with me. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay? That's your other option. If you are great at factoring, you can factor. If you're not great at factoring, then you just do the quadratic. What's she saying?
just ashamed of myself.
Why?
What?
For singing along with me?
Let's multiply.
So if you're trying to do it by factoring, you're asking yourself what multiplies to give you -9 times 14, but adds to give you 5. What's -9 times 14?
Good question.
Negative 9 times 14.
Uh-huh. What is that? You come in, Hudson.
Negative 126.
Negative 136.
-126? So 126. What are the factors of 126?
2. That's all I know.
2 and 63. Yeah. 2 and 63. Yeah.
That's not important.
9 and 14. Can a combination of 9 and 14 make 5x? I'm going to show y'all that factoring is really not that bad. So we're going to go to our factoring box. I have -9x squared and I have 14. And what did we say we need to equal? 126?
Sure.
-126, but we need to add to be 5. Well, -9 and 14, does that not make 5? So we have -9x and 14x.
Boom, we did it.
We did it. We factored. So now, once you're in the box, remember it's just GCF. What is the greatest common factor between these two? Just -x. That's all I
Yeah.
got. Greatest common factor between these two?
-1.
Greatest common factor between these two?
-9.
You see it like on that black folder on next to the lunchbox, or should be that one. And we get -9x, and GCF here is
14.
14.
Right here.
Yeah, just put it in the little, yeah. Yeah, you go. All right, so now I have my factors. So we have -9x plus 14 equals 0, and we have -x minus 1 equals 0. Can I solve it now? Can you tell me what my x's are?
I can tell you that one. It's once I do it in my head, I'm not tired.
If fractions are our friends,
No, they're not.
fractions are our friends.
They may be your friend, but they're not my friend.
Fractions are our friends.
60, Andrew.
So for this one, x equals -1. Yes, Andrew. And this one, x equals 14/9. Because fractions are our
And
friends. Okay, could you have gone through the quadratic formula and still got the same thing? Yes, you could have. It would have came out to be 14/9 and -1.
I don't got $20. Oh, that's my friend. I'm telling you, I got $20.
All right, so now that we have our x, can we solve for our y? Yes.
perhaps one do that.
You have to plug in both. So because if you have 2 x's, you have to have 2 y's. Does that make sense? It is. Welcome to linears and quadratics. So when we plug in, so the first one I'm going to do right here, we have y equals 5 minus 3 times -1 squared. We're going to do the easy one first. A negative times a negative is a positive. So 5 minus 3 is what?
2.
2. So for this one, y equals 2. Agreed?
Mhm.
Now let's conquer our fear of fractions. So y equals 5 minus 3 times 14/9. Wait. That doesn't look very fun to do at all.
This is why we don't like her.
Just type it in the calculator. But if I asked you in the fraction form, do you remember how to do it in the calculator and get a fraction?
Yeah.
So let's review that. So I'm going to go to my handy dandy calculadora. So my calculator is a little old, so I have to use parentheses, but 5 minus 3 times, and we have 14/9.
I don't think you did that right.
Oh. Times 14/9. Did I hurt that too? Okay, I'm just checking. And I want it to stay in fractions, so I'm gonna hit math fraction and to guarantee that I still get a fraction. And I get negative 61 over 20. So we now know exact y value for this guy, and its exact y value is y equals negative 61 over 27. So if it asks you for the exact, but you use a calculator to graph, it's going to give you a decimal, right? It's not going to tell you that fractional value. So be careful on what it's asking you for. So these are two pairs, 14/9 and negative 61 over 27. And negative 1, 2 is where it's going to intersect on this happy dappy parabola.
Ooh.
Okay, I actually drew the parabola the wrong way. It's a sad parabola because I have to subtract. So it should be like this. All right, so do we see the difference between linear versus linear and linear versus linear and quadratic?
Can we just keep it here?
No,
Why not?
that's not what our class is. You're no longer in algebra 1.
Can we do that?
All right, do we need to see another? Yes. Yeah. Another one. This is an example of a circle. How do I know it's a circle? Because the y is also squared. Okay, so this is a circle. And if I have a circle and I draw a line through it, it's going to do what? It's going to intersect in multiple places. Does that make sense? So it's another example of where you would have two possible solutions. Do we want to work through it again? Or it's the same process of substituting in? Or do we feel pretty good about it? Okay, so just if you choose to go back through and look, you're just substituting in for the y. So you end up with x squared plus negative 3x squared equals 10. And then you solve for x from there. Okay, and then you plug in and solve for your y. Cool. All right, this was actually easier because you just have to take the square root and not do a whole bunch of other stuff. All right. So we're good? No more practice?
No.
No? All right. Elimination method. So the elimination method is useful when there is no variable that has a coefficient of 1. Okay? So when there is a variable that has a coefficient other than 1, elimination can be useful. Now, if you're a person who likes fractions, then you can use substitution all day long. But if you're a person who doesn't like fractions, then elimination is your way to avoid fractions, okay? Or to try to minimize your fraction. So for example here, elimination is very useful when you have two systems that have coefficients that are opposites, that are the same but opposites. So that's a level 1 elimination problem. So when we look here, we have 2x minus 3y equals negative 2, and negative 2x plus 4y equals 4, correct? They have a coefficient that are opposites to each other, which means that I can combine these two and eliminate in order to solve for the other ones, okay? So the first thing you want to do is identify which variable you want to eliminate. So we're going to eliminate x. Why are we eliminating x? It's because it already has coefficients that are opposites of each other, yes? Okay, so therefore we don't have to do anything else. So step 1 and step 2 are good to go. I don't have to multiply, I don't have to manipulate. I just am good to go as far as combining. Step 3 is you're going to combine your two equations. So I'm going to combine my two equations. When I combine, notice what happens here with the 2x and the negative 2x. They're going to do what? They cancel, they eliminate each other out. Then I'm left with negative 3y plus 4y, which is y. And I'm left with negative 2 plus 4, which equals 2. So through elimination, I instantly found out that y equals 2. Once I find out what one of the variables is, step 4 is to take that and plug it back to any one of the originals. It doesn't matter which one. So if I choose the first one, if I choose equation 1, I'm going to have 2x minus 3y times 2, because this is what y was, equals negative 2. I'm going to go through the math. I have 2x minus 6 equals negative 2. Now I'm going to isolate. So I add 6. I get 2x equals 4. Divide 2. And I get x equals 2. So the solution of this system is 2, 2, which means that this is a consistent and independent system because I had one point of intersection. Does that make sense? Okay, this is a level 1 elimination. Why is it considered level 1? Because it already had 2 variables that could be, well, 1 pair of variables that could be automatically eliminated. And then once I eliminated, it then left me down to just 1 variable that was easy to isolate.
How many variables are?
3. Okay. Yes. Okay. All right, let's go up a little notch. Well, this is still level 1. So at another level, still at level 1. Why is this level 1? Because I still have a variable that's easy to isolate with no manipulation. And that's why. So when I combine, what do you notice happens? I get 0 equals 0. When this occurs, that means you have infinitely many solutions. If 0 equals 0, we have what? Infinitely many solutions. And therefore, this is a consistent but dependent system. Thank you, thank you, thank you, thank you. Thank you. Thank you. All right. So of course we would all want infinitely many solutions all the time, wouldn't we? We don't have them. All right, last one of level 1. Again, what do you notice happens here?
All the variables cancel out, but not the.
So we end up with 0 equals 4. Is that a true statement?
No.
No, 0 cannot equal 4. So what this tells us is that there are no solutions. And that's because this is an inconsistent system, which means that these are parallel lines. So we have an inconsistent system. So when it's 0 equals 0, that's a true statement. That means we have infinitely many solutions. When it's 0 equal to any other number, stop. Parallel lines, no solutions. It will never ever touch. Okay, we can't make this work. All right, those are our friends. Those are level 1 problems that we want. Like, yes, give me those, give me those, give me those. Are you gonna always get those? No. So let's just be real. Let's look at a 1. We're gonna go up a notch to level 2. Okay. Looking here. Is there anything I can easily eliminate? Nope. So this is where we have to manipulate. We have to decide on what we're going to eliminate. In this situation, does it matter if you eliminate X or Y? No. Just it's going to dictate what work you follow. Okay. So the first thing you got to do is decide, do you want to eliminate X or do you want to eliminate Y? What do y'all want to do? X. So we're going to eliminate X. So focusing on eliminating X, I have to make the coefficients the same but opposite, right? Same but opposite. So what you're asking yourself is, what is the least common multiple of 2 and 3? 6. So I need to transform 2 and 3 into a positive 6 and a negative 6. It does not matter which is negative. It does not matter which is positive. Just one has to be negative and the other has to be positive. So in order to make that happen for the first equation, I'm gonna have to multiply everything by what? So we're gonna do negative 3 on top. Okay. So we're gonna multiply everything by negative 3. To make that happen with the second equation, we're gonna multiply everything by positive 2. Agreed? So now our new equations that we're working with are negative 6x plus 9y equals 0. And then we're working with positive 6x minus 4y equals negative 10. So now after we've manipulated, we now can eliminate and solve for one of the variables. So what happens here? Cancels. 9y minus 4y is 5y. 0 minus 10 is? Divide by 5. So what is y? Y equals negative 2. So we now have our y. Okay, to solve for your x, you choose either one of the original equations and plug in your y. So I'm going to choose the first one. So we have 2x minus 3, but instead of y, we're plugging in negative 2 equals 0. What is negative 3 times negative 2? 6. What are the 2 steps it's going to take to get x by itself? Perfect. Subtract 6 and divide by 2. So what is x? Negative 3. So our solution set is negative 3, comma, negative 2. C. Okay. How do we feel about level 2 elimination? Good? Doable? No one's like, that's horrible. All right, so this is level 2 because the numbers are friendly. This is a level 3 because your numbers aren't as friendly, right? However, it's the same exact process. The numbers just get larger. All right. So the same thing is you're going to decide which variable do you want to eliminate? X, we're going to eliminate X. So we're going to eliminate our X's. So we're going to ask ourselves, what is the least common multiple of 3 and 4? 12. So how can I change 3 into 12? I'm going to multiply everything times 4. How can I change 4 into 12? I'm going to multiply everything by negative 3 because one of them has to be negative. So my new equations that I'm working with are now 12x minus 20y equals 44. And I'm working with negative 12x minus 21y equals negative 3. So now I can eliminate and combine. So we eliminate, we combine, and we get negative 41y equals 41. What is y? Oh, you wonder. Good wonder. So we now have our y. Now you have your y. And you're going to plug that back into the one of the originals. Doesn't matter which original you plug it back into. Nope. So we have 3x minus 5 times negative 1 equals 11. So we have 3x plus 5 equals 11. The steps to get x by itself are what? And so now x is by itself. So x equals what's 11 minus 5?
6.
What's 6 divided by 3? Is 2. So our solution set is 2, negative. Yeah? No? All right, so from here, it just becomes word problems. So all examples of possible word problems, setting it up when it comes useful, is where that's at, and finding the solution, okay? Using a calculator. So all left is word problems. Do we want to go through the word problems? Or are we feeling okay? So we can dive into 6-2. Okay, the other thing I wanted to show you on the calculator, is that if you get y by itself, like we did in the beginning, y by itself, for each one, you can always go to the calculator and find their intersection, either by looking at the table or at the graph, right? We all know how to do that, correct? So I assume. All right, so we're gonna just skip through calculator. All right.